So good afternoon. I hope you're all having a really great day. It's really exciting to be here at this conference, which has been organised by one of my employees, Sebastian. I'm going to be talking to you today about my experiences having led Ghost from its inception all the way to being just about ready to ship 1.0. And I'm going to focus on the technical challenges that we faced being an open source JavaScript application. So, it's going to work. Before I get started, I'd like to see if a show of hands. If you've heard of Ghost before today, can you put your hand up? Yeah, this always puts a smile on my face at the start of a talk when this happens. Okay, so I'm going to set the scene. I'm going to take you all back. It's 2012, and Ghost is nothing more than an idea. It was a little idea that WordPress had moved on, it had grown up, and it had become a full-blown CMS. And in its wake, it had left a gap, a space for a more focused publishing tool. And the idea was that if we focused on just publishing, we could build a more minimal UI and a more enjoyable writing experience, couple that with using Node, making it modern and fast out of the box, and we could build something which just gets out of the way, software that gets out of your way and lets you write. So Ghost was launched, it was bootstrapped via a Kickstarter campaign. In April and May 2013. And that campaign was an incredibly successful campaign. We raised around 230,000 euros. And we got some really interesting people coming and being excited about what we were doing. Now, during the Kickstarter campaign video, my co-founder, John, he explained this idea that although what we were talking about was building a very simple, very minimal blogging platform, the driving force behind it, the idea behind it that gets us out of bed in the morning is that we want to have an impact on the future of journalism. We want to build a tool that levels the playing fields and helps people to write important stories. And because of this focus, there were a few things that we really wanted to do that are perhaps a little bit different with Ghost. First thing, it's open source and it has a very permissible license. It's MIT licensed. The second thing is that we really wanted it to be super easy to install. We felt like we needed it to be accessible in order to get traction. We wanted it to be something you could just download and install on pretty much any platform. But very importantly, we wanted it to be backed by a not-for-profit organization. The idea here being that in a non-profit organization, you can make money, but all of that money has to be spent on the goal of the organization, on developing the software. And we can't get distracted by investors trying to change the idea or push us in a different direction. And so, another part to this, or to sort of back all of this up, we had this idea of creating a sustainable business model. So the idea here was that we would have a hosting platform where users could choose to pay us to host Ghost for them. And to explain this in a little bit more detail, the idea is you start off with some users and they want to pay you some money, and that money gets spent paying developers to build more features. Those more features attract more users to pay more money for the platform, and you get this sustainable cycle of growth that allows you to do bigger and better things as time goes on. But just to remind you that back in 2012 and 13, all of this was just an idea. It was a pipe dream, if anything. All we had were a couple of lines of code and quite a lot of ambition. Now, after the Kickstarter campaign, we set to work building Ghost, and it was about 6 months later, and only 2 weeks after the deadline we published in the Kickstarter campaign, 2 weeks, that's pretty good for a Kickstarter campaign, right? 2 weeks late, we shipped Ghost 0.3. And then we went on to, in December that year, we shipped the hosting platform that we were talking about, and that was everyone's Kickstarter rewards. So let's move on. This is what that version of Ghost looked like. It was very, very minimal. Now, in the time since we launched this version, we have really gone on to accomplish some really amazing things. The first thing is that within 11 months of launching the hosting platform, we were a profitable business. That sustainable business model is working. We've now grown the team to be 10 people, including the wonderful Sebastian and Kate, who's at the back. And we've shipped a lot of software. But the reason why we haven't hit 1.0 yet is there's still a lot of our original to-do list still left to do. This is my coffee table. This is how we planned Ghost. There are a lot of features that we haven't touched yet, and there are obviously new things that have come along that we've built instead, like Google AMP. Now, last year, we sort of put our heads together and decided to set a goal that we would try to get rid of all of the things that were really causing us pain, things that were slowing us down. Just identify the worst problems that we had and get rid of them. And with that, we were going to ship 1.0 as a backwards incompatible version of Ghost that solved all of the pain points that really got in our way. And as I said, we're getting pretty ready to ship that now. But along the way, there have been quite a number of challenges that have slowed us down. And I want to talk to you about what those challenges were and how we've solved them and what we're doing in 1.0. So the first thing I'm going to talk about is the split between the client and server and the battle to separate them properly. So to tell you this story, I want to start by explaining the sort of conceptual architecture of Ghost. There are three main areas to Ghost, the first being the JSON API. This is the way that you access data in Ghost. It's always had an API ever since day one, and it's a pretty standard JSON API. You can make GET requests, and you can get some data from it. And the second area is the server. This is what handles generating HTML for the front end of your blog. Now, confusingly in Ghost, we often refer to this as the front end of Ghost, even though it's kind of a server-side piece of code that generates HTML. And the idea here is we generate HTML, so it's almost like a static site generator, very close. We do lots of caching, and it's very fast. But you've got all the joy of having a dynamic application behind it. And the last piece is the client. This is where you log in to manage your content. This is an admin panel. And again, we call this the client, and we call the blog front end the front end. It's a bit weird, but hopefully I've explained it, and it will make sense for the rest of the talk. And those are the three areas. And what I've also put up on this diagram is the way that these pieces communicate with each other. So the client uses a pretty standard HTTP call to the API. So you can make a GET call, and you can put some query parameters on the end, and this API call to posts will return the 3 most recently published posts from the blog, because that's the most reasonable thing to return. Now, if you're on the server side, and you want to generate some HTML to put output, it doesn't make any sense to make a HTTP call. So our API is also available as an include. You can require the API, and then you can do something like this, api.post.browse. You can pass it limit3 as an object instead, and you'll get the exact same data back. And then recently we went one step further than this, and we made it possible to do the same thing in the theme. Our theme API uses handlebars, and we have a handlebars helper where you can do the exact same query and get the exact same data. So it's consistent everywhere. There is one way to get data out of Ghost. So this diagram, as I said at the beginning, is the conceptual architecture of Ghost. And it's quite idealistic, and it's not really what things were like back at the beginning, just after we'd launched the first version. Things were a lot more like this, with the client and the server weirdly coupled together in ways that no one really understood. In fact, an even better way of representing what it was like is this. There was a massive piece of the API missing as well. What happened was we tried to ship a first public version of Ghost, and we cut some corners. And the most obvious example of this is password reset flows, because they don't fit neatly into REST. Rather than spending the time to figure out how we would structure our API around it and how we would get that to work with the client API split, we kind of cheated and shoved some of the views on the server side and duplicated some rendering logic and some theme logic and some roots, and it kind of got a bit messy, but it worked, and we got it out. And similarly on the front end, we were using Backbone.js. Now, Backbone is a lovely framework, but it's not complete. It doesn't solve the whole story for building a front-end application. And so similarly, we cut some corners. Rather than spending the time we should have spent figuring out all of the tools we needed to build a front-end application, we just used Backbone and then cobbled the rest together. And we ended up with quite a few problems. For starters, you've got this whole, like, we're not sure if we're a single-page app or not. Some stuff's being rendered on the server when it really shouldn't have been. This ugly routing, sometimes Backbone is doing it, sometimes Express is doing it, and we had no data binding. We were binding everything manually, which is the most fragile thing ever. And we just had memory issues and all of these other problems. And it felt a lot like this. If we would put one more piece into the admin client, that the whole thing was just going to come tumbling down. And that meant that we had to do something about it. And I felt very strongly that we needed a new tool, a new framework. And I knew what all the problems were. I can enumerate those. But I really didn't know which one to pick, which framework to pick. I mean, it's always a minefield, right? So at this point, I embarked on my first ever attempt to make a technical decision in an open source community, which was terrifying. Because I was asking the open source community to have a debate about which front-end framework is best. So I thought quite hard about this before I did it. And I wrote a GitHub issue which very clearly stated what our problems were, and that the question we were asking was, which framework solves these problems? And I also said, I can delete your comments. If they're unconstructive, I will. And I did. Although I only had to delete 2, which was quite surprising. What we ended up with at the end was actually 100 comments. Some of them were like 500 words long. And they were all incredibly constructive, and they were from people all over the industry. People from Ember got involved, people who were really familiar with Angular got involved, everyone got involved. And but at the end of the day, we just boiled it down and realized that all of those problems we were having to do with routing and technical things were actually not the problem. The real problem is that we were lacking a clear, consistent approach. That without having a full tool, a bunch of open source contributors couldn't figure out together what the best way to solve a problem was without having lots of debates or whatever. And everyone had their own idea and everyone was working independently. What we needed was a rule book. We needed a very clear set of guides for how to do things. And if you take that to be your core problem, there is only one framework which really, truly solves this problem, and that is Ember. Ember is prescriptive. It tells you exactly how to go about solving a problem. And so we picked Ember. We went with it. And over the next 6 months, we built a new admin panel. Yes, it took 6 months. Most of that work was done by Ember contributors and other people from the open source community. Meanwhile, myself and Sebastian spent a lot of time filling that gap in the API. And at the same time as shipping this new admin panel, we also managed to ship multi-user. Up until that point, you could only have one user in Ghost. And we then very quickly shipped all kinds of other features that have been backed up. So we really unblocked ourselves and got from here to here. Notice the client and the server circles are still touching. We didn't quite get them quite separated. We still had a dirty trick up our sleeve. Instead of the Ember application fetching its configuration from the API, the server would render it into metadata, which is kind of really dirty. But it's okay, 1.0 is coming, and we've solved it. And we just bit the bullet and fixed it at last, and it's one of the things that just feels really, really good. Like, you've got some little dirty bit of code hanging around that you really should fix, and you can't. It's great, we've got there. We've finally got to this. So I just want to take a quick minute to reflect back on that story. This is one of my favorite examples of open source in action, and a really good example of the principle of standing on the shoulders of giants. That by leveraging all of the knowledge that has gone into the Ember framework, we then had a foundation and we could build higher. We were able to solve a lot more challenging problems than we were before. And that's the power of open source. And I often feel, because I'm very guilty of it myself, that the JavaScript community has so much open source software available to it that we've become a tiny bit complacent about it. Now, we owe a debt of gratitude to the Ember community for helping us. And I wanted to make a suggestion, because contributing is hard. It's really hard to get to know a new code base. But sometimes contributing can be the simple act of going and telling somebody who built something that enabled you, thank you. maybe you'll motivate them to have the energy to fix a bug today or build a new feature. So keep that in mind. Let's move on. One of the very first decisions I had to make when we were building Ghost was which database was I going to use? And here's another one of those scary debates. But I knew pretty much straight away, as soon as I looked at the data model, I wanted a relational database. And I was going to use an SQL database of some flavor. But I did recognize that that wasn't a particularly popular choice at the time, that people do quite like to have a choice. And so I looked around at the options and settled on picking a data abstraction layer. And there were a couple around that tried to cross the boundary between SQL and NoSQL, but they weren't very good. So I settled on Bookshelf and knex. Now, Bookshelf is like a data model library, and knex is an SQL abstraction layer. So we've got these tools, and now we have to pick a sensible default. So I went back to the original goals of the project, and the one that really informed this decision was that we really wanted it to be easy to install. In fact, we had a benchmark, WordPress. We wanted it to be easier to install than WordPress. And if you've installed WordPress, you'll know that you have to go and set up a MySQL database and get all your credentials sorted out. And if you're doing it on the command line, you've got to remember that grant all to blah by blah, identified by blah thing, which is a nightmare. And we wanted to get rid of that step. We thought we could do it. And the idea was we would use SQLite. Because it's a file. It's a file on your hard drive. There's no setup step. It sorts itself out. But SQLite isn't very much loved by our community. It's kind of seen as a testing tool, or it's for development. Nobody runs it in production. It's actually used for powering like launching nuclear missiles. But realistically speaking, it's actually the place where it falls down in terms of performance when compared with MySQL is not on reads, but on writes, on trying to do concurrent writes, because file locking is slow. And we were building a blogging platform, which hopefully would have lots and lots of reads and not many writes. And also remember, at this point, you could only have one user. So we didn't think we were going to bump into this problem quickly. So we thought, let's use SQLite and get some traction going, make it easy to install. So we launched the first version of Ghost. It had SQLite as the default, and MySQL as an option if you wanted to go for something beefier. And then when we launched the hosting platform, we also used MySQL because managing that many blogs just made more sense to use a service rather than a file. And that's how things stayed for about a year. And then some enterprising contributors came along and decided they wanted to add Postgres support. And all they actually did was fix a couple of very small bugs in the way that we were working that weren't compatible with Postgres and make Ghost accept the config. And then they said, hey, why don't we make Postgres support official? Now, remember, I did at the time think that having lots of databases was a good idea, and that the choice would help us to build traction. And in particular, with Postgres, at this time, Heroku was a very popular idea for how to host Ghost for free, and it pretty much only supported Postgres. So this gave us this whole new option. It seemed like a really good idea. And so for the last 2 years, we've had support for 3 different types of database. And we've suffered some serious pain as a result. The pain was not with reliability, performance, or issues with SQLite. No. I thought we might run into people having file corruption issues and lose all their data. Didn't have that happen. Very excited about that. But what we did have a problem with SQLite was it never quite lived up to that dream of being easy to install. And that's because it's a binary dependency. And that means you have to compile it on the environment that you're going to use it on. And compiling is hard. Now, actually, SQLite, at the time we shipped, in fact, they did it just in time for us, added a system which means that when you npm install SQLite, it doesn't do a compile. It goes to AWS and finds a binary that matches your environment and downloads it for you instead. And when this works, it's amazing. And when it doesn't, things like this happen. Completely unintelligible to any human being on the planet, errors like this. And our Slack help channel is just full of them, and I have lost, not years? No, I don't know, trying to debug these sorts of issues. And so it just hasn't been what we wanted it to be. And the other problem that we've really had has just been Postgres in general. It's really different to SQLite and MySQL. And I'm not saying that's a bad thing, but if you haven't got the experience of understanding those differences, it is really hard to track down bugs. Now, understandably, after the support was added, all of the contributors that had fixed bugs for Postgres, they all moved on. And we looked around and suddenly realized nobody in our core team had experience with Postgres, and certainly no one was using it in production. Bugs started showing up and not getting fixed. And then the straw that broke the camel's back was trying to add new features and losing days to trying to make Postgres work, and then all the additional testing of trying to test 3 different frameworks. So yeah, it just hasn't worked well for us. And despite trying to get contributors back on board, we just haven't really gotten anywhere with that. The last problem we've really had with databases has been migrations. And I think this is because Ghost's use case for migrations is quite different to most database migrations. Normally, a database migration is something that you run a couple of times on the production servers, a few staging servers, your development environments, and that's it. Whereas in Ghostland, a migration has to run on hundreds of thousands of blogs across 3 different databases, and that doesn't take into account that those have versions and flavors and whatnot. But even more importantly than that, Ghost treats the concept of installation and upgrading completely different when it comes to databases, because initializing a database, I don't think should ever involve rolling through every single incremental migration. That's just going to make the install process a nightmare, more room for bugs, and it'll just get slower and slower. And so the tools that are out there for doing migrations don't really have these 2 separate use cases. It's just incremental migrations. And so we've always had to have our own tooling, and our own tooling has sucked. And another problem that we've run into, again, has been knex doesn't really have much in the way of abstractions when it comes to doing schema modifications. So there's no way in knex to say, change the field type on a database, which means that if we want to do that sort of migration, we have to write it 3 times. So here comes 1.0 to the rescue. We're dropping Postgres support. Hasn't been the most happy announcement that we've ever made, but for now, we don't feel like we can support it. It might come back again in the future if we get more contributors, but for now, we're getting rid of it. And SQLite's not going to be the default anymore. We're going to have MySQL instead. And in this world, we hope that things will be a little bit smoother. Another thing we've done is we have ripped out the migration tool that we had and completely rewritten it. In fact, it's all done by Kate, who stood at the back. It's now available on NPM and on GitHub as a tool that anyone can use, and it supports these 2 use cases of initializing a database versus updating it. And with 1.0, we finally feel like we might have cracked the whole easy-to-install chestnut, the goal that we set right at the very beginning. Because we're shipping Ghost 1.0 with a CLI tool. So you'll install the CLI tool, and then to install Ghost, it'll just be Ghost install. Now, Ghost install will run a production install, so it'll try to use MySQL. It will try to set up your configurations, some SSL, all that sort of stuff, try and guide you through. If you are a developer who wants to build a theme, or perhaps you just watched this talk and wanted to see what Ghost was like, you can instead run Ghost install local. And that will use SQLite instead. And it'll just do a very quick install. It won't try and run you through any configuration. So, kind of hope that this is going to go much better from 1.0, that installing and also upgrading Ghost is going to get significantly easier, and we're going to reduce a whole bunch of pain. So, another thing that I wanted to talk about today was structuring an Express application. And this is something that's interesting to me because it doesn't really seem like there's much in the way of discussion or advice or even sort of examples out there in the wild past a certain sort of level of complexity. And so there's been many a day when I've looked at our application and gone, there has to be a better way, and sort of Googled it for an hour or two and tried to look for somebody who's got a better idea for how to do this and can't find it. So this is what we've done, what we've learned so far. Going back to the beginning, Ghost 0.3. The very top level of Ghost hasn't changed at all. We've got two folders. The first one is the content folder. Content is where all of your sort of user-provided stuff goes. So if you've got a theme or some images, it goes in the content folder. And then core, which is all of the software that we provide to you. And inside the core folder, there is a server folder. And inside the server folder is where all the fun stuff starts to happen. So looking at Ghost 0.3, this is the server folder and all of the stuff that we had inside of it. Now, I think you can see quite clearly from this that we were using model view controller, MVC kind of pattern. And I've got this little contrived example of why I think this works quite well with Express. So this code snippet, you've got app, which is your Express instance. It calls out to .get. That means a get request. And the first argument is about. So what it's saying is, if the server matches a request for get about, then the next function should be executed. And just to demonstrate what I'm saying, I called it my controller. And then inside the controller function, there are two lines. One which deals with going to get some data, so talking to your models, and the second one which handles rendering a view. And so you've got all of these pieces in a standard Express routing sort of syntax, which are very, very similar to models, views, controllers. And you've got this extra layer of routes and, of course, middleware once things start to get a bit more complicated. Now, I've noticed that when you're building an Express app, things seem to start quite simply, like this. And then very quickly, your file grows into like a monolith, with just endless stuff, your server being initialized and middleware and routing all being in one file. It kind of expands out. And this was way worse back in the beginning of Ghost when it was Express 3 and there wasn't as much control over the router that you have now. So in the most recent version of Ghost, we can see that we've made some progress towards improving this structure. There's a lot of extra bump in here as well, but you can still see models, views, and controllers. And there's two new additions, middleware and routes. So sort of taking that huge Express app start file and breaking it out into its component pieces. However, when we started to do this, we still ended up with one of these like ridiculous files. And it was our middleware index.js file, which we kind of tried to leverage some of the new Express features and break Ghost out so that there was a different Express app for the admin panel and for the front end. But the way that we did it, we just ended up with this sort of interlaced, interlocking middleware calls, which were very, very, very carefully ordered, because if you moved anything, it would break. And it just, this was my least favorite file in the code base for at least a year. Just a complete nightmare. Anyway, again, here's 1.0. It's coming. And 1.0 is this liberating opportunity for me, because for the last couple of months, we've just been shipping alphas, so I can break everything, and it's fine. And so I started breaking that middleware file down into its components, and now we've got 3 individual Express apps, one for each of those conceptual components that I was talking about at the beginning. The JSON API has its own Express app, so does the server and the client. And they then all handle their own routing. The admin panel doesn't have much, but just the one route. But this starts to work a little bit better. To try and demonstrate where this is going, because this refactor is in progress, I've kind of skipped ahead and made a little branch where it's how I expect it to be, or I'm hoping it's going to be, in the future. So taking all of those libraries that were hanging around like mail and whatnot and shoving those in a lib folder, you can then start to see the structure simplifying again. And if you look inside these 3 applications, you see that we've got, all of them have got an app.js file, they've all got middleware, Two of them have roots. Admin only has one root, so that is in the app.js file. And then they've all got some sort of concept of a controller, something which deals with rendering. And so the improvement we've made here is that as the application gets bigger and bigger and bigger, if you divide everything up by folders, well, in order to sort of follow how your application is working, you have to go to the roots folder first, look up the root, and then find out which middleware is called and which controller gets called, and then sort of follow it through the application. But by breaking it out into pieces and grouping the logic together, we start to make our code base easier to understand again. And with these three different applications that we've got, we then sort of mount them onto a parent like this. So they all get mounted onto one Express app, and then that Express app gets exposed to the world. So I've got one more example of this sort of breaking things down that I wanted to quickly show you, which comes from our original front-end controller, the piece of code that dealt with rendering your blog. So whether you wanted to render a post or a list of posts or an RSS feed and so on. That was another case where it started off really simple, one file was good enough, and then as time's gone on, it's gotten bigger and bigger and bigger. And also, we've started to realize that we've got some duplicated concepts, so maybe we should start to break those apart and restructure this. So this is a really good example of three principles that I've learned really work for us. First of all, to solve real problems first and dry it up later. And because more use cases result in better abstractions. And to go back to the example I just showed, what we found was we built a list of posts page, and then we built a list of posts by tag page, and then a list of posts by author page. And we were kind of like doing the same thing over and over again, even though they were quite different. And suddenly we realized that we had this different way of looking at the data in front of us, which we called a channel. So a list of posts is a channel, and that if we broke those things down into a primitive or an abstraction, that you can have a channel, we could make that customizable and suddenly start making Ghost really flexible. Like you could have a channel for every featured posts, or every post tagged with 2 tags, and so on and so forth. So I think you can find some little bits of wonder when you start to try and figure out how to break your application down. Breaking files down into packages as they get too complex, but not before. This is something that I'm a great believer in, is like sort of doing it just in time. And then also that applies to when you move something from being an internal package to actually giving it its own repository and publishing it on NPM. Trying to do that stuff up front can give you a lot of overhead. And the third thing is using index.js to expose public APIs, and by that virtue, exposing only your public APIs to avoid tight coupling and circular dependencies. This is something that I keep getting bitten by. I keep going, oh no, it seems messy, I'm not going to do that again, and then coming back to it because it seems to be what works. And when I was thinking about these 3 principles and this idea of sort of pulling applications apart and restructuring them, I sort of struck by this idea of this sort of ever-expanding application. It reminded me of like the Big Bang and the universe expanding around me and life getting more complicated. And I suddenly thought, maybe this is a force of nature, maybe this is how things are supposed to be, and that my personal, natural tendency to fight complexity as it arrives is, maybe I should just let that go a little bit and see how things plan out. So I'm going to try this as my 2017 resolution, sort of just, see how it rolls. Anyway. This is some of the challenges that we've been facing, some of the things that have really slowed us down over the last few years. But that we've made loads of progress and we've really cracked a few of them. But there is one thing that we have not yet tackled, which actually makes me feel quite nervous about talking about. It makes my stomach turn. Permissions. So who can do what with which resources? And this is usually sort of tied to your API. And yes, it's one of the biggest reasons why our API, despite having been there since day one, isn't really exposed to the public yet. It's because we just haven't nailed this part. Ghost has its own tiny little library for doing permissions, which handles that exact set of relationships. So there's a who, there's a what that they're acting on, and there's what they're doing, their action. And that's really similar to the sort of stuff that you'll find on NPM. Now, I found a really good example on NPM. It's got some great documentation that really illustrates the point for me. Here you have how to define a role. So you start off with a group, which is a user or users, and then start defining rules for these people. So the resource that you're acting on is users. So this is what users can do to other users. And now we've got methods. And what strikes me here is that these methods are all HTTP methods. So that's never going to work for Ghost because of our API having more than just HTTP access mechanism. We need this to operate on a lower level. But there are other modules around that do this same thing. And they can operate like as middleware or as just as function calls. So there are things around. So the other way that I want to explain why I find this so terribly limiting is to tell you about the question that we get asked constantly. Why can authors publish posts? And I understand from an organizational perspective why you might want to have an author role which isn't allowed to publish a post, but is allowed to create and edit them. I totally get it. But from a technical perspective, in Ghost, publishing a post is editing a post, changing the status from draft to published. It's an edit action. It's a put operation in HTTP. And the way that our library, and in fact most of the libraries I found work, don't give me access to the attributes on the resource that I'm talking about, at the point which I need them in order to determine whether or not somebody has the permission to do something. And so I've done quite a lot of research, and we've worked on this, on trying to figure out what solution we're going to use for this. Things that are on NPM all seem to be quite simple. I've looked at academia. Those things are way too abstract. And there just doesn't seem to be a really clear solution to this. It's also something that's always completely missed from any textbook about REST APIs. They're like, add some permissions. And I'm like, yeah, how? So anyway, if you have built a system like this and you would be up for a chat, I would love to hear from you. So, wrapping up. Obligatory plug. I've talked a little bit about Ghost 1.0, so let me just cover really quickly what is actually in the box. We're going to ship a brand new editor. We're replacing our existing split screen editor with mobile dock. It's going to make it way more customizable and extensible. We're shipping the SQLite tool that I mentioned that's going to handle installs and upgrades. We've got this snazzy new idea that we're going to have a centralized auth system, which is optional, but if you use it, it means you can share users between Ghost blogs no matter whether they're installed on your server or on our server. And that will give us access to doing all kinds of fun things that normally we can't do because we're decentralized. And there's improved logging and migrations and all kinds of stuff. So, last thing, what's next for Ghost? Right back at the very beginning of this talk, I talked about how the driving force behind Ghost, the thing that gets me out of bed in the morning, is the idea that one day I might be able to have a positive impact on the future of journalism. And last week, we launched Ghost for Journalism. Now, this is kind of like a journalism accelerator. We're looking for 3 organizations that are about to start new publications, and we're going to effectively sponsor them or help them get going. And we're going to dedicate our team to building the features that they ask for so that we can align Ghost with what journalism really needs. And we've got some ideas about what that might look like: subscriptions, memberships, letting them take payments, all kinds of really exciting features. But I'm just super excited about being able to finally tackle that deeper, longer-term goal. It's amazing to finally be here, to finally be able to ship 1.0, and thank you all very much for listening.